How does the workpiece affect your robotic soldering? Imagine trying to solder a tiny, delicate circuit on a workpiece that's rough or uneven. The way the workpiece behaves during soldering can make or break your project. When you're working on robotics projects, building and prototyping, every detail counts. The material of the workpiece is a big factor. For example, printed circuit boards often have coatings like gold plating or organic solderability preservative. These coatings can affect how well the solder sticks. If the surface is oxidized or has a poor finish, solder might not flow properly, leading to weak joints. Sometimes, using stronger fluxes or higher temperatures can help, but if the base material and coating don't match well, problems still happen. Over time, exposure to moisture or heat can make the surface less solderable, so it's good to check solderability regularly with test patterns before doing the full job. The shape and size of the workpiece also matter a lot. Complex shapes or tightly packed components can make it tricky for the robotic arm to access the solder joints. If the robot can't reach or apply heat evenly, you risk cold joints or incomplete solder coverage. The thermal properties of the workpiece are another key point. Some materials, like metals, absorb heat quickly, while plastics or composites might need longer heating times. Adjusting the soldering temperature and dwell time helps ensure the solder flows well without damaging sensitive parts. Flux plays a big role too. The type of flux used and how it interacts with the workpiece surface can cause spattering. Spatter can create messes, interfere with inspection, and requiring extra cleanup. Choosing flux formulations that minimize spattering is a smart move. Inspection is vital because workpieces can change during storage or handling. Using vision systems to check each solder joint right after soldering helps catch defects early. This is especially useful when working with complex geometries or variable surface conditions. When programming your robotic soldering system, understanding the material, surface finish, and shape of your workpiece helps you set the right temperature, flux, and path. Testing with sample patterns and inspecting joints ensures you get strong, reliable connections every time. Paying attention to these factors makes your robotic soldering process more consistent and efficient, especially when building or prototyping robotics electronics. Remember, matching your soldering approach to the specific workpiece characteristics is key to producing high-quality results that last.